So for lab 3, we're doing a melting point of all our substances, and we have some historic data that we are going to compare everything to. So we've got a different file. This one here is the one that contains all our mass data, and this one here now contains our melting point data, and we'll have a separate one as well for our TLC data. What I've done is I've made up a data file here just so I can show you what we're supposed to do. So this is the historic data. This is from 2017 to the previous year. In this case, is 2023. And this would be our new data. So for the year 2024, the year that I'm making this video, let's say that this is our new data set. So I've just come up and just made a random data set here. The columns exactly match the other set of columns here. That's important that that happens. And I'll make sure that we do that when we're in lab, and we input our data. So in lab, you will actually do your melting points, and then you're going to need to tell me what the start and the finish, start and the finish, start and the finish, start and the finish, and so on for all of these data sets. And so what we need to do now is we need to merge these things together, and we're going to concatenate them. So essentially we want to add this 2024 data right after this 2023 data. And in order to do that, we're going to call in both data files as a pandas data frame. So we'll call this one, say, df1 and this one df2 as the variable that will be assigned to that data frame. And then we're going to do a concatenation on it and combine them together. As well, we're going to be able to save them as a new file. So right here, we're going to save this as a new CSV, and we'll see what the output looks like. So here we're going to go in, we're going to import pandas as PD. So df1, we're going to import the first file. So what I've gone and done is I've put the file into a new lab notebook. So under notebooks here, mine was starting to get really busy. So I'll let you take a look. Woo! And so what I did was I made a new file folder here. And as long as all the information is within the same file folder, you're going to find that it's going to go pretty flawlessly, so which is quite nice. So what you can do is you can do a lab 3 here. You can put a new notebook called, sorry, a folder called lab 4 and so on and so forth, and actually keep all your data straight. I've got to go and do that for my notebook and put everything in. But regardless, I uploaded these two files here, the historic and the new data that we're going to put in. And what I was able to do then was using this from a previous example. So here was the previous example. What I did was I needed to input the new path here. So what I was able to do is go here, copy path, and then you can just sort of highlight this and do Control V, and that will place it in. And since you're in the same notebook here, their data's in the same notebook, I don't need any of this information here. It's a little bit extra, and I can delete that, and there it is. There's my new extension that's on there. So I'm going to copy path as well. Hopefully I copied that. Put that in, Control V, and I can get rid of all this extra stuff here like that. So this is not the one we're going to do. It's an example, but this is essentially what we're doing here. So we import that in. So I've imported the Lab 3 historical data. I'm importing the Lab 3 2024 example right here. So that's our new data, two different data frames. And then I'm going to call it final melting point data. And so I'm going to do on the pandas data frame, I'm going to concat df1 and df2. And I'm going to ignore index equals true. So that it skips these indices here, and it'll just have this go straight down underneath. And then I asked it to display the final data so I can actually see what the output is. And then I also asked it to save it as another CSV file. And so this one's called Lab 3 melting point data combined. And what that does, it allows me to work on this as a separate data file, or I can continue to just keep using the variable here, final data MP. This is now a data frame that contains the two concatenated data frames. So I can actually do descriptive statistics on this. I can do a t-test on this. I could, or use it for a t-test. I can do a variety of different things. Use the group by function on this to separate out all the lab day data or all the year data. But there's our new, essentially like our new data frame that we called in previous examples. So we can continue on with this one here and keep doing whatever data analysis we would like to. As well, we can save it to a separate file, and then you could open another window if you wanted to and just work on this specific file. So I'm going to run all, and hopefully it works. And so there it is. It spit out the same thing. There's 18 columns here, so it stayed the same. Both of these files have 18 columns. It has so many because we've got, for my example anyway, we've got so many examples because we've got uh, duplicates. So we've got tube 1 and tube 2, and you're going to find that when we actually run the data, we've got two sets of data for each melting point that we're going to do. And we've got a little bit of extra, no, we don't. I thought we had some redundant work here, but we don't. So we've got here then the crude melting point, so for tube 1, a start and a finish, and then for melting point of the crude tube 2, start and finish, and then for salicylic acid, tube 1, start and finish, and then for tube 2, start and finish, and so on. ASA's tube 1, finish, start and finish, tube 2, start and finish, then the recrystallized, which we're working on as well. So the recrystallized data here, tube 1, and then this is supposed to be tube 2. Oh, sorry, still tube 1. Sorry, tube 1, start and finish, and then tube 2, start and finish. And that's our entire data set. And now if we scroll down here, we've got down to the 2023 data. We want to append this. And so if we run this, we should be able to see then our new file that we've created. I'll open that up. So this is our Lab 3MP data combined. And what we did was we asked it to create that file right there. And this is it. And so it's in the same notebook here, which is pretty cool. And so now if I scroll down here, we're going to see the 2024 data is right here. Okay. And what that does, it just makes it easier for us to go through and use group by to actually figure out what's going on. We can do stats analysis by calling in one data frame, say this one here, and then calling in a second data frame and working on that as well and trying to compare statistical analysis or t-test or whatever by doing two different files. My preference is to call them in on one single file and then just each of these levels, so each one of these different sets of data here that are part of one group is kind of a level, it's called. So this is group R and this is group S and so on. So if we want to compare group S to group R, I can do a group by function, pull out this data specifically, and then refer to specific columns. So now that we've concatenated these two data frames together, data sets, and we have our 2024 data, we need to start working on the analysis. The only thing to realize though is that we've got two tubes worth of data for each melting point that we've done. So here we've got a melting point crude ASA1 start, and we've got an ASA2 start. And we actually need to average these together first before we can do the analysis. So we're trying to essentially combine all of these data sets here, average out every of the 1 and 2 column headings, and create essentially a new column heading based off of these. So right now we're currently at 18 columns, and we're looking to essentially increase that, unfortunately, but we are going to work on the average data set for our analysis. So in order to combine these together, now that we've got this, we've got two ways of doing this. One, we've got a data set here now called MP data. So we've got all our concatenated data, and we can do averages for the different column headings that way. Or we've also got it saved here as a combined CSV file, and we can work on it either way. So what I'm going to do is I'm going to show the example that we use for the box plot. So it was in our descriptive analysis lab 0 work sets, and we're going to modify that to work with this. So I've already done a bit of that already, but so here, what I'm going to do is I'm going to import pandas as PD. I'm going to create a new data frame, and I'm going to read in this new data set that we just created. So here, we're creating a new data set right here, saved as combined CSV. So I can either call this in and the new CSV, or I can just keep using that final data. But I would need to then copy and paste this cell directly underneath here and continue using the data here. Okay, so either one of them works. Like I said, we already got the concatenated data frame right here, and now all we got to do is start averaging the different columns. Or in this case here, I'm just using the example from the box plot. We've created this CSV file, and we're going to start averaging the data there. So the next thing we need to do is get a list of our columns. Now we have a list of our columns over here in these data sets, but it's hard to go back and forth between them. So what we're going to do is we're going to print out the actual columns of the data frame right now. So in this case, DF columns, if we were to use this here, we would say final underscore mp data dot columns for to get it here. So that would be the same thing as the df would be that final one, and print out just the column headings. Once we do that, we're going to get a list here like this of actual column headings. And if I can go like this in between the quotes, or actually even using the quotes, I can hit Control C and then Control V in order to get the actual heading without making any errors on it. So that's why I do this. The next thing is you'll notice I'll skip to this here, but this is the actual, it's creating a new column. So in the data frame, create a new column here called average. So this was for the box plot data, and we'll see it's for box plot information column 1 and information column 2. And so if we combine these, it's going to create a new average. So we're going to apply the same idea, but we're going to do it for the melting point. So I'm going to create a new thing called average MP, and so this is going to be for our ASA, and it's just going to be the starting melting point. So for the average ASA starting melting point, it's going to be the average of ASA1 and ASA2. And so to get those values, I created this in, I typed this, and then I went down here for this, and I just copied ASA1, and I hit Control C, and I came up here, and I hit Control V like that, and that was it. And then I was able to get that information. So if we're to do it again, I'm just going to copy this. Just makes it easier. So copy this one, Control C, do it again, Control V, and now I can do the next one. So now I need the finish. So I want the crude finish here like this. Again, Control C, and I'll put it here, Control V, and I want the crude finish 2. So you can see it's a bit difficult. Make sure you get them right. So Control C, Control V, like that. And I also need to change the name of this. And so I'm going to call this finish. So now at this point, we're able to get a new column called average MP melting point ASA start and average melting point ASA finish. So we'll get the start and finish for the two columns. They'll be combined together. And we're going to print out that data frame, see what it looks like. And I've hashtagged these out. So rather than hashtagging like this is for a single line. If I want to hashtag out more information, so if I got all sorts of stuff here, use these 3 quotes. It doesn't have to be the double quotes, it can be single quotes, but you want to make sure it's the same on the top and the bottom. So if you do 3 quotes and 3 quotes, everything here is hashtagged out. It's a way of, at the very beginning of your Python code, to be able to write a whole bunch of information about it. So let's go through this again. I'm calling in the data frame as this CSV file. I'm going to see what the columns are right here. I'm going to start to average them. We should see some new columns pop up. Remember before we had about 18 columns, I believe, and we've hashtagged this out. And I'm going to print out the new set of columns after we've done this. So we've got this print columns up here. We'll see what we've got when we start, and we'll print the columns again after we're done. So let's try running this and see what happens. Hopefully we don't get an error. So it doesn't look like much has happened different, but I'll tell you there should be some new columns. So there's all the column indexes here like this. When we scroll down, it's now telling us we have 20 columns when we used to have 18. And if we look here, when we printed out the column headers now, we've got an average start and an average finish. So we've got these 2 new columns that we can now do the data analysis on. So you're going to keep doing this copy and paste and so on for all the rest of them. It shouldn't take too much time, hopefully, as long as you remember what to do. So Control C, I'm going to hit this, I'm going to hit Control V, and then I'm going to start cutting and pasting again, or copy and paste. So I've got my crude finish, crude ASA2. Let's see how easy it is. Control C, and I'll do this one, Control V, and I need the MPSA SA start 2. So that one there, Control C, Control V, like that, and then I need to change my name here, and this has to be a start, like that. All right, and so that should get us our new data set. If we were to run this, hopefully we get some new column. We'll see we've got 21 columns now, and we see our new average right there. All right, And again, so just keep cutting and pasting or copying and pasting and doing exactly what I did to kind of finish off the data set. Once you've finished off this data set, then we can actually do box plots, we can do regression analysis, we can do, in our case here for the melting point, we're going to do some t-tests and ANOVAs. So, and just to show you what it would look like in the original file if we're to do that, so instead of calling in our newly saved CSV file, if we were to continue doing the data analysis here, we would want to add this information essentially here into a new data frame, sorry, into a new cell. So here at the very top, so this is the starting point. So we've created DF1, so we're reading in this historical data file, then we're calling in our new data. We've combined them, concatenated them together, and we got this display. We know that we've got 263 rows and 18 columns worth of data, and now we need to average it. So this information here we put into the next cell. And so what I've done then is I was saying that we've already got our data frame saved as this final MP data variable here, and so we can just act on this. The problem is that everything we just did previously has df, so we've defined it as df. So there's two things I can do. One, I can either take this final data, I can copy it and paste it over top of each one of these instances of df. So that's one thing to do. Or the other is I can just simply redefine final data as df and then continue using this. So this one here is lazy, but super easy, which is what I did. The problem, there's no real problem with this other than that this assigning a variable to another variable takes up memory and time. But we've got time. It's not that big of a deal. But for the Python programmers out there, this is not very Pythonic as they call it. So at least I don't think it is. But it made it easy for me and super easy to do. So if we're to now just take this variable here that we've already assigned, so we've created this new data frame and we've called it final MP data. And since I've already got these called over from here, I just copied and pasted it. I'm just going to assign df variable to this variable, so nothing new changing other than the name of it. And I'm going to now on the data frame df, I'm going to create a new column based off of these two. And so if we run this and we print out the columns, we'll see that it's the exact same output for before. So there's our new column headings like we had before, so from the original. And then now as we add in, there's 262 rows of data still. But we'll see at the bottom here that we've now got 3 new columns. So there's the average ASA, the average ASA start and finish, and the ASA start, salicylic acid start that we defined up in the top. We'd have to continue on using these. And if we look here now, we've gone from 18 columns to 21 columns. We've increased the 3 columns, and we'd have to keep adding more and more here until we get the extra columns finished. So you got either route to do it. This is the preferred route here because what you can do is keep this all in one Jupyter Notebook file, and when you save it, all this information will be combined together. This is definitely the preferred way to do it. It's just here I was showing the example that we've already had from a box plot example, but now we're taking that box plot example and pulling it into another cell. We're starting to combine different statistical analysis and manipulations from cell to cell to cell as we go through. So at this point then, we've got a data frame called in. We've combined the new and the old data frame together, and we've now are averaging 2 columns. And at this point, once we finish off these columns here, these new columns, this is what we're going to do our statistical analysis on.